All right, next section is graphing sine and cosine. So important thing to note is that the unit circle period, we're going to stick with radians, period is 2 pi. That's going to be the period of sine and cosine because that's one full rotation. And then we're going to apply transformations, left, right shift, vertical stretch or compression, horizontal stretch compression, and vertical shift to these functions to get the graph sketched. So these are called your sinusoids. They're your wavelength functions. It's just a repeating wave. So I've given you the graph of sine based straight off of the unit circle, so table of values shown. Easiest way to remember how to graph sine, I call it Sahala. So that means we start sine, S, at an axis point. An axis point is kind of like the midpoint between the highest and lowest of the wave. Then we go up to a high, back down to an axis, all the way down to a low, and then we just continue that process over and over and over. So this last A here is a repeat of that first A. So that tells us there are 4 unique, what are called critical values in each period of sine. Here's your standard transformation form of sine. That's going to be very important for this section, and it gives you the values of what each variable A, B, C, and D stand for, and then the formula for the period or wavelength of the function as well. All right, sketch at least one cycle of f of x equals 2 sine of 3x. So you can find all this information in any order. It's kind of up to you. I have a certain order I like to go in. So first thing I'm going to calculate is I like to go start with the period. So the formula for the period is P equals, it is 2 pi, because that's the period of the parent function, over the absolute value of B. So if we look at our formula here, there is no C, there is no D, B is 3. So our period is going to be 2 pi over the absolute value of 3, which is just 2 pi thirds. So that's how long it's going to be before we make one cycle. The sinusoidal axis, this is what I call the midpoint between the high of the wave and the low of the wave. So our sinusoidal axis is at D, and since there is no D, it's going to be at y equals 0, so it's going to stay in the same place as the parent function. Then we need our wave height or our amplitude, which is the absolute value of A, which is 2. So what that means, from our axis, we will go up 2 to get the high of 2. We go down 2 to get the low of -2. Then we need to get our critical values figured out. We need to know where our critical values are going to fall. So that's where the Sahala is going to come in. We also need to know what we're going to count by. So we count by 1/4 of our period, because remember, there are 4 unique critical values in every cycle. So we have to divide the period up into 4 equal chunks. So 1/4 of P is 1/4 of 2 pi thirds, which would be 2 pi twelfths or pi 6. So that means we're going to have a critical point every pi 6 units. All right, phase shift. The phase shift is that starting critical value. So it's like your left or right shift, C. But because we did not have a left or right shift, our phase shift is at 0. So now I want to figure out my critical value. So what I like to do is I write out Sahala. And our first axis point is always at our phase shift. So the first axis is going to be at x equals 0. Let me scooch this stuff over a little bit. And then from there, we add the count by each time to get the next critical value. So the next critical value, the next x value, is going to be 0 plus pi 6, which is going to be at pi 6. Then we add another pi 6, so that would be 2 pi 6. Make sure you get them simplified. So that would be pi third. And then another pi 6, so 3 pi 6, which is pi half. And then another pi 6, so 4 pi 6, which is 2 pi third. And we just keep repeating this process over and over and over as we go out. So it says sketch at least one cycle. Usually in the online homeworks, they'll have more than one drawn for you. But I think if you sketch one out, that'll be enough for you to figure out which graph is correct. All right. I'm going to try my best to make them very even. Copy, paste. Should have drawn this out beforehand. Copy, paste. Copy, paste. I also like to show one negative critical value just to show you what's going on over there. Sometimes you'll have to do more than one negative depending on the phase shift. In this case, we need one. I'll do one. 1, 2, 3, 4. That should be good. All right, let me get my highs and lows. There's one. Copy. Paste. Copy. Paste. Try to make it pretty. Okay. All right, I'm going to get my critical values labeled. So these are our pi 6, and then pi third, pi half, 2 pi third. And then negative critical value, we would then go to the left, so subtracting pi 6, which would put us at 0, subtract another pi 6, which would put us at negative pi 6. All right, highs and lows, we said our axis is at 0. Our amplitude or wave height is 2. So from the axis 0, we are going to go up to 2, and we are going to go down to negative 2. Sometimes it's helpful. I'll put a dashed horizontal line through here. Let me find my dashes. Just to kind of remind myself where that sinusoidal axis goes, but you won't see that on the online homework. But if you're drawing it by hand, that sometimes is helpful just to remind you where it is. And then we just map it out. So x equals 0 is our first one. That's our axis point because we did not have a phase shift. So at 0, I put my point on the sinusoidal axis. I go over a critical value. I go up to a high. So at pi 6, we're at a high. Back down to my axis at pi thirds, all the way down to the low at pi half, and back up to 2 pi thirds. Then I can see that's one cycle. Then we just mirror that image back to the left. So from 0, we would have to go down to negative 2. And then we play connect the dots with our little wiggle. Actually, you know what? Before I do that, we're going to try to save some time. Let's see. Copy. I'll try to copy. Oops, that's not what I'm trying to get it to do. Come on, draw the arc, please. There we go. Sometimes it just really doesn't want to do what I want it to do. That's okay. We get our arrow. Okay. So there's our curve. Next one. Cosine. So cosine, here's the parent function shown. Easiest way to remember cosine is, I call it chala. So cosine starts at a high point. So if you think about off the unit circle, cosine right at the angle 0 is the 1, and 1 is the highest cosine's allowed to go. Then it goes down to an axis, a low, an axis, and then same as before, it repeats that high. And if you actually look at the two graphs are actually just a phase shift apart because sine goes axis high. So if we just shift the graph to the left, we wind up with the same function. All right, so there's your two summaries, Sahala versus Chala. Make sure you know the A, B, C, D, and how they affect the graph. The nice thing is it's done in the same way. All the values you calculate are found the exact same way. Only difference being sine go from an axis to a high. Cosine start at the high, then go to the axis. All right, sketching the graph of 3 cosine x minus pi half minus 2. All right, first thing, period. Formula for the period is 2 pi over the absolute value of b. And if we look at our function here, b is 1, so it's just going to be 2 pi. I'll go ahead and put the 1 in there so we can remind us it was 1. All right, so there's no change to the period of cosine here. Then we need our sinusoidal axis. Also need our wave height. Remember, the sinusoidal axis is the midway point between the highs and the lows. Our sinusoidal axis, which is the vertical shift factor, is -2, because we went down 2. And our wave height, or amplitude, is the absolute value of A, which is 3. It's the number sitting in front. So that means from -2, we will go up 3 to reach a high of 1. We will go down 3 to reach a low of -5. Then we need our phase shift. Our phase shift, remember, it's x minus in the formula. Minus go right, plus go left. So our phase shift is, we're starting at that critical value, x equals pi halves. All right, so now we need our count by. Count by. There are 4 unique critical values in cosine, just like sine. So we take the period and divide it into 4. So 1/4 of 2 pi, which is pi half. So we're counting by pi half. All right, this was cosine. So we're using Chala. All right, phase shift is where we start. Our phase shift was at pi halves. So pi half is going to be that starting point at this high. Then I add a count by to it, pi half plus pi half, 2 pi half, which is pi. Then I add another one, 3 pi half. And another 4 pi half, which is 2 pi. And another 5 pi half. And then, again, I'm going to draw another left one as well. So if you wanted to map your lefts out, you could by just subtracting pi half. So pi half minus pi half, the first point to the left would be 0. And then if we take another pi half away, we would be at negative pi halves. All right, let me see if I can get this graph dropped in. I'll do a little erasing, maybe. Okay, so you go away, you go away. Nope, we're going to erase. Still erasing. Let me see how well I can get that. Oopsies. All right, how close can I get to the dots? One more. Oh, no. I always do that. Okay, close enough. Get rid of that axis. All right, that may not have saved me any time, but whatever. Copy, paste. Make sure I get one negative. We do hit 0, so I'll line it up with 0. And we'll go. We'll see about that. This time I'll copy it now. Copy. Okay, so let me get my critical values labeled. So pi half is the first one past 0. Pi, 3 pi half, 2 pi, 5 pi half. And then 0, we don't label 0, and then negative pi half. All right, highs, lows, let's see, what were they? Axis is at -2, so I'm going to shift this down a little bit. 2 lines. All right, so axis -2 and height 3, so that's going to put our max at 1. So we need to make sure it's above, and then it's going to put our minimum at -5. So -2, those are dots. -2 plus 3 puts us at 1. -2 minus 3 puts us at -5. All right, so sinusoidal axis, if you want to draw in, just to kind of remind yourself where it's supposed to be, since we did have a shift down, and then I can get my criticals in. So my main critical value, that starting phase shift, pi half, and it's going at a high, which was at 1. Then I go back to my axis at pi, down to my low at 3 pi half, back to my axis at 2 pi, up to the high at 5 pi halves. Then we mirror that image back to the left. So at 0, coming back to our axis, and then at negative pi half, down to the low. And then we play connect the dots with our graph. A little wonky on the end, but that's okay. All right, next. So just like transformations you saw in college algebra, you can have the same transformations with any function. So with sine and cosine, remember a transformation when the a value is less than 0, that is your reflection across the x-axis. So that folds it along the x-axis. Well, if we fold it along an axis, the axis points aren't going to go anywhere, but your highs are going to drop to lows and your lows are going to drop to highs. So anytime the a value is negative because of that reflection, this is what's going to happen to Sahala and Chala. So our sine, if a is negative, we swap all of our highs and lows. And with cosine, when our a is negative, we do the same thing. We swap our highs and lows. So we wind up with Salaha versus Klahal. At least one cycle of -2 sine of 2x minus pi half. So one super important thing you want to make sure you catch with this function is it's not in that standard transformation form. So if you want to identify your phase shift, it's helpful to rewrite that first, because the phase shift is not pi halves. So what we need to do, I forgot my sign. It's kind of important. Separate the 2 from the x, and in doing so, what that means is we need to take the value sitting at the back of that set of parentheses, and we need to multiply it by the reciprocal of b. So this right here, in order to get it factored off nicely, we're going to multiply by the reciprocal of it to get it into the right format. So that's going to give us, so kind of like unfactoring it, but it just doesn't factor nicely. Or I guess factoring it. So we have 2 and then x minus pi 4. Close, close, plus 3. Now we can identify our stuff. All right. Period. Wavelength 2 pi over the absolute value of b. Because again, we might see a b negative in a minute. That's why the absolute value bar is there. So that is 2 pi over 2. So we have a period of pi. Our axis, sinusoidal axis, is at y equals 3. We went up 3. Our amplitude or wave height is the absolute value of a, which is 2. So again, be careful. The amplitude is not -2. You cannot have a negative wave height. The amplitude is +2. And then our phase shift, we went right pi force. So there is our starting critical value. And then we need our count by. Put the count by beside it because we use those together. 1/4 p. So 1/4 of pi. So I'd rather write it as pi force. All right. So I just remember sine, Sahala. So what I would be doing here is we've got sine is Sahala, but because of the negative out front, we want to make sure we swap our highs and our lows. So Sahala is going to change, and we're just going to switch the H's and the L's. So we're going to get negative Salaha. And this is what we're going to use to get our graph sketch. I'll draw the graph next to it. All right, starting critical value is our axis point at our phase shift, which is pi over 4. So there's that main critical value. All right, then we're going to add pi fourths each time because our count by is pi 4. So we've got our pi 4 plus another one will be 2 pi 4, 2 pi over 4, pi over 2. Then we have 3 pi over 4, 4 pi over 4, simplifies to pi. Then we have 5 pi over 4, and you could keep going if you wanted to. Then we're going to go back to the left. The other reason you want to go back towards the left is to make sure there's not any more before 0. So subtract a pi 4, we get 0. Subtract another pi 4, we get negative pi 4. So there's our criticals. All right, graph. Paste. Oh no, I didn't copy my graph. Oh well, I'll just redraw it. Doesn't take that long. All right, we get an axis. Get all my little copy paste. Copy paste. And that should be good. All right, 0 was one of our critical values. So that means when we draw in the axis, it is going to go through one of these. So I'm going to go ahead and draw it through there. Let's see, highs, lows. Axis is at 3, going up and down 2. So from 3, we drop down to 1. And then from 1, or nope, sorry, up. So 3 down 2, minimum of 1, and then 3 up 2, max of 5. All right, so axis 3, down 2, up 2. All right, critical points labeled. I think it was pi 4. All right, pi 4, yes. Pi half. 3 pi 4, pi, and 5 pi 4, and then 0, and then negative pi 4. Axis, if you'd like to draw it in, I do think it's helpful, but not necessary. Just always dash it, don't make it solid. All right, pi 4, we are on an axis. Then pi half, we're down to a low, because remember our H's and L's swapped places. 3 pi 4 back to the axis, pi up to the high of 5, 5 pi 4 back down, and then mirror back. So if I connect the dots back to the left, I know that from that pi 4 moving to 0, next point is going up. So we go up to 5, and then we go back down to the axis point. Get our wiggle drawn in. Oop. Guess that sometimes it hates me. Here we go. There we go. All right, so we've brought in A being negative. Well, then what happens when B is negative? So that's your horizontal stretch compression. A negative B is a reflection across the y-axis. Rather than dealing with the transformation, we want to bring in those even and odd identities that we've already discussed. So for cosine, remember cosine is even, which means the negative is just poof, it's gone. So a negative B, we can just drop the negative because a reflection on the y-axis, cosine's symmetric on the y-axis, so it has no effect on it. For sine, sine is odd, so a negative inside becomes a negative on the outside. So instead of dealing with a negative B, we can just bump it outside and continue going through the process. All right, -2 cosine negative pi x plus pi halves. So first things first, it's not in the correct format. I'm going to separate the negative pi from the x, which means that pi half has to be multiplied by its reciprocal, 1 over negative pi. You got to get it factored off correctly. All right. So we've got our -2 cosine negative pi x. Negative times positive, negative. The pi's divide out. We get 1/2. All right, negative inside. This is a cosine graph. Cosine is even, so a negative on the inside, poof, drop it. So it's as if it never existed. So we're going to be graphing -2 cosine pi times the quantity x minus 1/2, close, close, minus 5. So a negative inside for cosine, we just drop it. There, it's symmetric on the y-axis, so they have the exact same graphs. All right, now we can find all of our information. All right, period. 2 pi over b, absolute value of b. So 2 pi over pi. Period is 2. Sinusoidal axis. Y equals -5. Amplitude, or wave height, is the absolute value of A, which is 2. Remember, amplitude can't be negative. So from -5, we go up 2. So -3 is our high, and then we go down to -7 is our low. Phase shift. That's that starting critical value. We went right 1/2. So we're starting at x equals 1/2. We need our count by. Count by is 1/4 of p, and p was 2, I think. Yes, 2. So 1/4 of 2 is 1/2. So we're counting by halves. And now we got what we need. All right, cosine. So I always go look first. Cosine is chala, but it is negative. So we're not using chala, we are using Clahol. Swap the highs and the lows. So again, this is not what we want to look at. We are using negative cosine, which is Clahol. Highs and lows swap. H's become L's and L's become H's. All right, phase shift was right to 1/2, so that means this first low is at 1/2. Then I add a count by, so if I add 1/2, I get 1. I add another 1/2, I get 3 halves. Then I get 4 halves, then I get 5 halves. Mirror back to the left, subtract 1/2, we get 0. Subtract, let me scooch you over, another 1/2, we get -1/2. I always go until I get 1 negative. Graph. Copy, paste, nitpicky details. Let's go a few more. That should be good. 1, 2, 3, 4, 5, 6. Okay. All right. 0 is one of our critical values. So since 0 is one of our critical values, that means I can put my y-axis in here. Actually, since everything was negative, we'll drop it a little bit. All right. Maximum, minimum axis. Our axis was at -5. And then we went up 2, so it's going to stay negative. and then we went down 2. So -5, up 2, down 2. All right, get the critical values on there. -1/2. Oops, we're going to kind of run into that. 1/2, 1, 3/2, 2. Oops, let me go more. I want to get the 5/2 on there. Okay, that's it. Nitpicky details. Axis, I like my axis. That's not a dot. All right, graph. 1/2. Notice how I put my main starting point in a different color just to remind myself that's the one I start with. I do think that's helpful. You could also use a highlighter. So 1/2, we are at a low. So what would be at -7? At 1, back to our axis, 3/2, up to our high, back to our axis at 2, down to the low, add 5/2. Mirror that shape back. So at 0, we're going to be on our axis, and then at -1/2 at our high. And then we play connect the dots. And again, it's hard to draw by freehand. Luckily, I have an iPad that auto cooperates most of the time. Just make sure it's rounded as best you can. What you don't want to do is sharp zigzags. All right. All right, next one cycle of this one. Actually, you know what? We're gonna, because I just realized everything seems to be going right. I want you to have one that's going left. So we're gonna, whoopsies. We're gonna magic so that this matches your notes. I wanna do that. So your copy will have the minus in there. All right. Yeah, we don't need to go right every time. We gotta go left at some point. All right, first it's not in the right format. So careful, algebra no, do not add those two together. That 2 is attached with multiplication. That 3 belongs at the back by itself. So separating the -pi5 from the x, which means the -3pi5 must be multiplied by this reciprocal. So just flip it. It's -5 up, pi down. And then that 3, I think, yeah, it was a 3, goes at the back. Right. 2 sine -pi5 times the quantity x minus, the 5's drop, the pi's drop, double negative makes a plus 3. All right, sine. A negative inside bumps outside because sine is odd. So we're going to take that negative that was on B, and we are going to slide it out and attach it to A instead, since sine is an odd function. All right, let's find our info. Period, 2 pi over B, or over the absolute value of B. So in this case, it's 2 pi over pi5. Keep it, change it, flip it. Division by a fraction is the same as multiplication by its reciprocal. So 2 pi times 5 over pi. Pi's drop, we get 10. Axis. Call it the sinus axis. We went up 3, and our wave height, amplitude, is 2. So up 2 from 3 puts a max at 5, down 2 from 3 puts a minimum at 1. We need our phase shift. We went left 3, minus go right, plus go left. So that's going to be that starting critical value. And we need our count by. 1/4 of P, and P was 10. So 1/4 of 10 is 5/2, or 2.5, either one. All right, sine, Sahala. But remember, it was negative. We are not looking at Sahala. That's not what we want to use. So swap my H's and L's. So I'm going to rewrite it with the H's and L's flipped. All right. Starting critical point was -3. All right, we're adding 5/2 each time, or 2.5. As far as writing these, when it's a nice pretty decimal, I don't have a problem with you using decimals. That's totally up to you. I tend to just stick with fractions because most of the time they're going to involve pi, so we kind of got two to begin with. All right, so that would be a little fraction math here. That is -6/2. So if we add 5, we get -1/2. We add another 5, we get 4/2. We add another 5, we get 9/2. And we add another 5, 14/2, which is 7. So this time, I don't need to go to the left because I already have a negative critical value right here. The other thing you want to notice 0 is not one of your critical values. So that means we will not be putting an axis high or low on the y-axis. We cross the y-axis, but not at one of the values. All right, tick mark to death. That's the annoying thing about these graphs. Is takes a lot of details. All right, so since we don't actually hit 0 before I draw my y-axis in, I'm going to go label my critical value so I know where to put it. So let's see, -3, -1/2, 2, -3, -1/2, 2. 9/2, 7. Oops. And let's see if we add another 5, that would put us at 19/2, 24/2. So in this case, because 0 is not one of your critical values, you can't just stick the y-axis in there. So my y-axis is going to be between -1/2 and 2, and I am going to draw it closer to the -1/2, just so it looks a little more correct. All right, highs, lows, axis is at 3, and then up and down 2. I guess I could scooch this up a little bit since I don't need any negatives. All right, 3. Up, down, axis to help. Oops, missed. All right, points. All right, main one, -3 is our axis. Then we go to a low because it was negative. Then we go back to our axis. Notice none of those dots are on the y-axis because 0 was not a critical value. Back to a high, back to an axis, back to a low, back to an axis. And then play connect the dots. And there's our curve. Next one. This time, the graphs are given and we're asked to give an equation in terms of both sine and cosine. Remember, sine and cosine are cofunctions, which means they can be written in terms of each other. So there's technically a whole lot of equations you could write here. We'll go over several of them just so you have examples. All right, so you've got to find all this information. What you find first is kind of up to you. If I'm looking at this, the first thing I notice is that sinusoidal axis because the dashed line here is drawn in. So right there is that sinusoidal axis, so that tells me D. So I know our axis, sinusoidal axis, is at y equals 5. So that tells us that D is 5. So I got D done. I'm going to do A, B, and D, and then C, the phase shift. The phase shift depends on which trig function you want to write, whether you start at a high, an axis, or a low. So C is the last one we're going to do. All right, now that I've got the axis, I'm going to go get my amplitude because I can see a high is labeled. So the amplitude is the distance from that high. I don't need any dots anymore, so let's get off the dots. That distance from that high to that axis point. So if I look here, the difference from 12 to 5 is 7. So that tells us our amplitude or absolute value of A is 7. Actually, I don't want to do it in colors. We go back to my normal color. So our amplitude is 7. All right, the period. Okay. So if you notice, a period, remember, is where the cycle starts over. So if we look at our graph here, I go from a high to a high here. That would be a full period, but notice I don't know how far away that is. So I can't use the full period, so we need to figure out what percentage we have. Remember, there are 4 unique critical values. So there's 4 chunks to it. 1, so there is a 4th. 2, 3, and then 4. So if you look at this, I know this length here from 2 to 11 is 9. And if I look at the portion of the period, it is 1, 2, it is 3/4 of P. So the distance from 2 to 11, 9, is 3/4 of the period. You could be given a 1/4, a 1/2, 3/4, or the full. Sometimes you're given more, but not normally. So I know 9 equals 3/4 P. So if we do a little math here, multiply both sides by 4/3, we get 12. So the period is 12. Now that we know the period, we can use the relationship with B to figure that out. So the formula we've been using is the period is 2 pi over the absolute value of B. But if we resolve this for B, because that's what we're missing, we know P, I get the absolute value of B is 2 pi over P. They just swap places. So now that we know P, we can plug that in to get B. So 2 pi over 12, we get pi 6. So B is pi 6. All right, I have A, I have B, and I have D. So I'm going to write equations for sine and cosine, and we'll go from there. So f of x equals 7 sine of pi 6 times x, and I'm going to leave space for c because I don't know what it is, plus 5. And then for cosine, 7 cosine pi 6 x space plus 5. All right, for sine, remember sine is Sahala. It goes from an axis point to a high point. So if I look at the graph we are given, there are 2 axis points shown. The first one is followed by a low. The second one is followed by a high. So this is the one right here we want to use for sine because it's on an axis and then it heads up to the high. So for sine, that is right 11, so I would put minus 11. So this format's fine. I prefer this format to multiply it out, but the textbook at times does like you to distribute that pi 6. If it wants it distributed, just make sure you multiply it through. Scooch that down. All right, cosine. Cosine, Chala, starts at a high point. So if I look at my graph, my high point right here is at 2. So that would be a right shift 2, so I would put a minus 2 in. So both of those are correct. So just pay attention. If it says give it in terms of sine, you have to give it in terms of sine. All right, second one. All right, doing the same kind of thing. So let's see, looking at this. So I have a high marked and I have a low marked, but I don't have the axis marked. But the axis is still going to be that midpoint in between. So the midpoint between 5 and 6 is 5.5. Try to keep it right in the middle. So D equals 5.5. From D, we go up and down the amplitude. So if I'm at the 5.5, there's not a whole lot of room to go up and down. I can go up a half. So our amplitude is a half. All right, we got D, we got A, we need B. So I need to figure out what chunk of a period we are given. So if I look here, 15, it's a little bit hard to see. 15 is that high point? Yes. 15 is our high. 100 is our low. So we go from a high to a low. So if we look at how much of a period that is, it helps put some dots in here. I've got, let me get them marked here. We've got 1, 2 of the 4. So 2 of the 4 is a half. So we have half the period. Half the period is the difference between 115, which would be 85. So 1/2 P equals 85. So I'm going to move all that down here. So 85 times 2, 170. So the period's 170. Formula for B, 2 pi over P. So pi 85. All right, let's get our equations written out. Fractions, decimals, it's up to you. I think I put sign first last time. Leave some space. D, 5.5. Which is 11 over 2. Or 5.5, it doesn't matter. All right, so looking for sine. So if we look at this graph here, I've kind of written all over this little graph right here. But if we look at our graph for sine, sine starts at an axis followed by a high point. So if I look at my graph here, an axis followed by a high point, I got to get over here. It's not labeled for me. I could try negative sine because negative sine goes axis low, but it's also not labeled for me. So here we're going to have to use our count by. We got to figure out what those points are. So remember, your count by is 1/4 of P. So we count by 1/4 of P, and P was 170. So if we divide that by 4, we are counting by 42.5. So if I take 15 and I add the count by to that, 42.5, so if we stick another count by on there, so we have our 42.5 plus 15, that puts us at 57.5. So I could use that one and give the graph of negative sign. It doesn't say positive sign, it said sign. So I would rather do that. So I'm going to stick a negative here, and we'll scoochy that, and I'm going to put it there. And then I get my phase shift, which was, we added the 42.5 to it and got 57.5, which I'm going to leave as a decimal. If you don't want to do negative sign, add another, just go back to the 100 and add a count by to the 100, and that would give you the positive sign. All right, for cosine, cosine starts at a high, where our high is labeled. We can see that it's at 15. I'm trying to use a different color here. We'll just change it. There we go. So right there's our high, and it's on 15. So we'll just use that one. So write 15, so minus 15. And there's your functions. All right, the word problem, I'm going to do in a different video because this one's already long enough. So watch the second one for the Ferris wheel.